Hello, everyone. I think we'll begin. I'd like to welcome everyone to our Temerty speaker series. And today's speaker is absolutely phenomenal. I'm going to be very privileged and honored to introduce him very shortly. But first, I'd like to go through a few acknowledgements and housekeeping items. We wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. The Temerty Center for AI Research and Education in Medicine, or T-CAIREM, at the University of Toronto has been made possible by the generous donation of the Temerty family. T-CAIREM is an interdepartmental center that serves as a focal point for collaboration among healthcare providers, trainees, researchers, computer scientists, engineers, industry, and so forth to advance health through artificial intelligence. Our goal is to transform health through AI. Just a quick mention, this event is CPD accredited, so to obtain your CPD credit, please complete the evaluation form that we'll email to all attendees following the event. And don't forget to provide your name and email address on the evaluation form. Another note to attendees, please use the Q&A function in Zoom to submit your questions to Dr. Friend. He will address them during the discussion portion of the webinar. And we also have a live Twitter feed, so you can follow along and respond to what's going on. Be sure to follow the hashtag Temerty Center Speaker Series. So now it is my honor and privilege to introduce our distinguished speaker today, Dr. Stephen Friend, who has an incredibly calming last name. So our guest today, Dr. Stephen Friend, is an authority in the field of genetic resilience, cancer biology, and digital health. At the Dana Farber Cancer Institute and MIT, his team cloned the first human cancer susceptibility gene. While on the faculty at Harvard, he was jointly recruited with Lee Hartwell to co-found the Seattle project at the Hutch, and then co-founded and led Rosetta Impharmatics, where they developed RNA expression approaches to assess the aggressiveness of breast cancers. Merck acquired Rosetta, and as Senior Vice President for Oncology, Dr. Friend rebuilt the cancer franchise using molecular profiling techniques, which would later show value in assessing the sensitivity of tumors to Keytruda. After working at Apple from 2014 to 2017 on digital health, he is now a co-founder and president of For You and Me, the founder and chairman of Sage Bionetworks, and based at Oxford University as a visiting professor of connected medicine. Dr. Friend is both an Ashoka Fellow and an AAAS Fellow. Incredible accomplishments, just a very diverse set of experience. We're very privileged and honored to have Dr. Friend present to us. Thank you so much, Dr. Friend.
It's a pleasure to be joining you to have a chance to talk, and looking forward to getting things going. I'm going to go ahead and share my screen here and confirm that this is working. And if you can confirm that this is this working okay?
Once you push the...
Looks great.
Yeah, it's great now. Perfect.
Great. Okay. All right. So I'm going to talk about digital devices and how they might allow us to follow symptom transitions. And I have this phrase, the fabric of life, the effects of fabric of life on chronic conditions, which I hope will make more sense as I go through today. I'm going to go back and start with what it feels to be healthy. When we look at an image like this, it becomes self-evident. We know it when we see it, although I doubt there's any effective algorithm that's able to parse that. There's an element of being able to have the freedom to do whatever crazy things we choose to do. And possibly health most deeply at its heart is about the freedom to explore, self-actualize. Incidentally, this is Ian McKay, a strong believer that nature is one of the best medicines. So this is sort of like where we're trying to get to stay within. The reality is that there are lots of things that are awkward realities of how medicine is carried out today. Things that we just like to avoid, we sort of stay in denial, whether it's this concept that courses of disease are rather linear, to whether it's about the missing ability to say what actually is going to occur for an individual, be able to forecast it, to the gaps in terms of being able to make insights to help guide the people at an individual level. And of course, virtually all of it assumes that interventions are to be provided by experts for a fee. So this is the sort of the setting. And the other really important thing that we may come back to, maybe even in the question and answer, is that virtually all of medicine is done the way chemistry was done in the 18th century, which is by alchemy. And it's our ability to observe things, to say A happens when D occurs, without having much knowledge of the rules or the principles that are underlying why things happen. So remember, think of it as still stuck in the age of alchemy for physicians. And the other aspect is that even today, this concept that when we get sick, we give up our agency sort of in the bargain for being able to be healed, and really have not yet regained a way where we could have that agency, is all about the existing realities. So how do we change that? This is a diagram that's about embryonic stem cell states, but I hope makes the point that what you would like to be able to do is to be able to have contour maps where you could look at transition states, but instead of looking at it for embryonic stem cells, you could look at it in terms of where anyone's health is around any symptom and what might happen if you were trying to go from one state to other. So if you look ahead, this is what one would like to be able to, in fact, you would argue, in order to do that forecasting, one will need to be able to build such maps for aspects of disease. And so starting about 10, 12 years ago, we started asking, how could wearables change the way we're looking at symptoms? That is, instead of having the periodic evaluation by a clinician using their senses, how could the sensors, whether it's on phones or watches or otherwise, how could they mimic aspects of our own five senses? And we began projects with funding from the Robert Wood Johnson Foundation to ask, what would it take to be able to gather that information? Could we have what we were then calling participant-centered research studies with feedback loops? Could we have ways where the study participant and the researcher were less asymmetric, that the data and dialogue that was going on would go back and forth? The concept is, if we couldn't do this, we doubted we could get the labels in order to have that understanding. So we began to think of where in wearables could we do such participant-centered research studies with feedback loops, specifically around changing anecdotes in the signals. And these projects began using what you would expect was available then in terms of mobile phones and smartwatches of various types. And in that interval between 2012 and 2014, it became apparent that if there was a way by which researchers anywhere could do remote wearable studies where that data could be pulled in, where it had the right consents, et cetera, that it was worth having a kit for that reason called Research Kit that was a way to do medical research. And so Sage teamed up with Apple to see if there was a sort of a template to use to build a series of these early queries into how you might use wearables, not connected necessarily to an institution, and pull in the data and get the findings, et cetera, and put it in the open domain. The one that we worked on particularly was one around Parkinson disease. I just want to point out a couple of things here. In Parkinson disease, taps, gait speed, balance, voice frequency were all part of the tools a clinician would pull together as an aggregate score and say, for this UPDRS, Universal Parkinson Disease Rating Scale, this is where a patient is. And one of the nice things about having an ability to look over thousands of individuals that we were able to recruit is we could take any one individual and look in different dimensions at their disease. So if we rank ordered 30 individuals on the top for TAPS and then asked what's their gait speed, balance, and voice frequency, purpose of this slide is to show that the severity of the disease was actually quite different depending upon what lens you used into looking at what that disease was. And that when you could separate out from that aggregate score, you'd get more information, you'd have a better chance of knowing where that participant was. So that's the inter-individual diversity. The other is to ask questions about the intra-individual. So here's one individual, 4 months, 120 days, and you could go and look at what their scores were in one test, tapping test, pre-post medication. And as you can see here, there are times when there's a good bump from the medication. There are other times when there isn't much. Sometimes even for that person on that day, pre-post, there is no upswing in terms of enabling activity from the L-DOPA. On the bottom, the other thing that was important was we had a way of recognizing when someone's symptoms had changed, and therefore we could send a query that asked them why. Why do you think you are better or worse as you followed the symptoms? And the anecdotal things that came back from the thousands of responses that we had, I'm pointing this out because it's going to go to what I'm going to talk about later in centeredness and stress, would be things that were saying, I got a new cat, or my neighbor moved away, or my son is now living with us. So the things that were affecting the physical disease. So notice not the mental, but the actual physical parameters in the disease were things that had to do with sort of how that person was going through their life, and that interested us. The other thing that now in the 2014, 15 through 2017 timeframe began to happen is people began to want to pull in and what I'd say is weave together the data streams that were coming off, the objective, the subjective data stream, and ask if you could take data that was off different sensors, somewhat related around a particular symptom, in this instance around cognition, could you pull together and make more sense by using the phrase multimodal sensor streams? And it's with that this minute level behaviogram hopefully can help show what was deemed important to do. You could take things as diverse as what's going on someone's phone, to heart rates, to acceleration, to surveys, and begin to ask questions that you couldn't ask when you have machine learning or AI as a tool to go, what is going on? At this time, what really became sort of an open set of questions were the following. Could we use the sensor data to overcome binary presentations? Could we collect massive sets of multimodal longitudinal data to follow symptoms, not just symptoms? Could we find that the AI compositional layers, the way you look at imaging and find those compositional layers and anomaly detection for images, be possible to do for symptoms? Could it provide ways for people to track and share what was happening to them, etc.? And so we began to think about whether it was possible to build out a platform whose learnings could nurture, and instead of sending it out to a large tech company or to an insurance provider or a clinician, was there a way to actually work to give that back to individuals? And so in 2017, coming up on 5 years ago, we formed a nonprofit called For You and Me with the explicit goal of seeing whether we could tackle the unknowns about using wearables and phones to enable individual forecasting of symptoms, and how to effectively return it to individuals that were wanting to navigate their own health and disease, and also set it up where all the data, the findings, the algorithms, the apps could be put in the public domain. So that's the story now that I'm going to sort of unwrap, and talk about what we have been doing. The structure for this is to have a very small team. The For You and Me list over there is basically everyone in the center For You and Me, full-time working there for the thousands of individuals that are being recruited and going through the studies. And we do that because we rely on coalition partners that have expertise in clinically following patients, or in building apps, or in doing assessments of the analysis, the AI, machine learning, etc. And so we find that for each study, we can put together best in the world, leave them intact, have them connect with us. So that's the structure that we've chosen to do these feasibility studies with this small internal set. Going to a little more detail on what we mean by saying we can take this diverse set of signals from the sensors, like smartphones, smartwatches, or other devices, and how do we weave that together? Going down the y-axis, cognition, mood, sleep, gait, fatigue, you can see that depending upon what symptom we're wanting to follow, we can get complementary data that's coming off of these smart devices to help us follow it. So this is sort of the general way that we take this data together. When we have those engineering signals that are coming off the devices with the smartphone passive and active data, then, for example, for a symptom such as stress, we can go ahead and look at the objective and subjective signals of stress and connect it to end organ. I hope this roadmap is beginning to come together. So 2 years ago, we had in the hopper coming through about 12 feasibility studies. And they were a wide set of them for particular various reasons. 2 of them had made it to the funded protocol submitted level, and the rest of them are either awaiting protocol or earlier. But fortunately, this year, where there are now 13 studies, one of those studies is completed. There are 6 of them that are ongoing, 1 or 2 of those that I'm going to particularly address today. And most of the other ones are, on their way to beginning to give data back over the next couple of years. So we're going to go to the completed study, the stress and recovery study. And this is one funded by the Gates Foundation that worked closely together with Evidation, with Vector, with a number of sites to ask 2 fundamental questions. One was, could we use that phrase that we mentioned earlier from the Robert Wood Johnson funded studies, participant-centric approach? We use this participant-centric approach to engage individuals who are using these multiple digital devices for high-resolution data capture for extended periods of time involving high-friction assessments. There's really a feasibility of, would people stay with this? Would they be able to be engaged? What would happen? Second was the feasibility around detecting and tracking changes in immediate and intermediate stress using these tools, particularly in this population of frontline healthcare workers who were being swamped by all the things they needed to do in the interval of this study. So using that structure that we were talking about before, trying to find those signals. One of the things we knew, and this is an example of an article that Abhi Pratap, who is now up there working with you, we were lucky enough to have him part of groups at SAGE, had pointed out earlier, is the survival probability by duration of the study, no matter what study you were looking at, it generally has a pretty severe drop-off rate as measured by days into the study. And we're interested in going, was there a way to flip this, to make it so that was more able to get long-term data in studies with the wearables? So we used that participant-centered philosophy I was talking about earlier in this study that went on in 2020 into 21, that had almost 400 individuals that were enrolled, almost 300 that were retained, 4 to 6 months, and on whom we had the smart rings, the Garmin watch, and the study app, and had set it up in a way where throughout the study, bi-weekly, those individuals would be followed by what would normally called CRCs, but we shifted to calling engagement experts, where their goal was not to have a truant officer check in, offer suggestions on why to do things more, but really as a person who was there for the healthcare worker to listen to what was going on. And so during that enrollment interval in 2020, looking at those individuals coming in, being part of that study, there were individuals across all 50 states that we had participating in this. And then we had Zoom calls where we brought everyone who wanted on and had individuals who were willing to listen and talk to us and give questions, give us feedback. We changed the design of the study during it. We added, so this was to see what we could do. We also had subarms that we brought up later. Here is an example of the retention and adherence that's in this stress and recovery study, which was better than the light touch. So here is high friction, high touch, as opposed to those light touch studies. And so on the scientific side, we were wanting to ask questions about the distribution of all parts of the measures. We wanted to see if we could identify periods where there are very high and very low stress conditions, and how did that match between subjective and objective digital measures. We wanted to see if there were identifiable periods when the signs of high stress and low intermediate stress, similar to 1A, 1B, we're looking at intermediate, not immediate stress. Wanted to know if there were associations between those four quadrants. Really then back to asking, could we see things among stressful conditions that affected, et cetera. So these were the hypotheses that have been driving the work. Here's some of the data. This is a participant, a female, aged 30, in which you can see that her combination of heart rate variability, respiratory rate, and temperature is doing a cyclic pattern that you would expect if someone was having hormonal cycling. So we could tell that this was sort of like a sanity check to see what was going on. Later, I might go into the fact that sometimes these seem to ablate, and whether they ablate during stress, and is that a way to follow stress, is there. We found this interesting. Here is a set of individuals, same individual, same color on heart rate variability and heart. Look at the variation. This is looking at how variable across the entire study were their nighttime average measurements of heart rate or heart rate variability. And what we found interesting here was a lot of individual variation and intra-individual variation like we had before. If we took the aura data only and we were able to look at the various parameters being measured, we could look at whether something was correlated or anti-correlated, pink and blue, across those various signals that were coming out. Here's 6 individual. I hope this is able to be seen not by the individual measures, but just if you look at those grid patterns, what you can see is the differences that are going on in terms of between individuals, the variable correlation between those various measures. Same time, back to this intra-individual variation. Here's one individual, same individual at different times. So we began to be thinking about wiring states and what's holding someone together and how they're reacting, how's their body functioning in times of stress, and not just between but within individuals. So the preliminary findings are, I think, even more than we expected. The noisiness of the data at that N of 1 level that one could expect, but wow. And we began to search for clues of anomalies, altered states, or periods when individuals were out of sync. And so that type of data and this work has been done brilliantly at the Vector by people in Anna Goldenberg and Marcia's team, people like Sujay and Sindhu and Gopal. They've been looking for change point detection of correlations and decorrelations. So you see how we're drilling in one more layer to ask, what is it that's driving these features? And in identifying those anomalies or stress states, like how do you define an accurate change from baseline normal? Could you look at change point detection of correlations between the features? Could you disconnect the self-reported subjective measures and objective measures? Could we look at disruptions of the expected rhythm? So these are the approaches. This work is ongoing, but thought it was worth showing and highlighting the work there that was being is going on at Vector. If you want to get to a write-up of the study and how it was done, it was published in December. But more importantly, I'm showing this because at the bottom you'll see that there is the data and all the things you would want to do to query that data set we've put up on Synapse. And so anyone who now wants to go in and work with that data while we're working with the data is welcome to go do that. And a little different than some of the existing sets that most people have. In terms of ongoing studies, the study that is the largest one going on right now is one, it's called BUMP, for Better Understanding Metamorphosis of Pregnancy. And this one was done by looking through the very large set of symptoms that are occurring among women who are becoming pregnant, going and finding certain ones, like this spider chart shows for 3 of them in the gold, blue, and red, where the existing sensor data was deep enough that we felt, for example, for fatigue, we could pull enough data feeds to do that multimodal data approach. Similar for emesis, similar for cognition. So using that approach, we went to 8 symptoms from fatigue through to stress that we said, can we build individual portrait maps? Can we do all those things we were talking about before, individual differences? In this instance, they not only had either an app, because this is an ongoing study, it started just over a year ago, about a third of the way in, that has an endpoint of somewhere between 800 and 1,000 individuals that make it all the way through. So it's a large study. They either have their Garmin Venue or Apple Watch on. They have a Aura Gen 2 or now Gen 3 ring will be used to collect a number of objective data points. And also a great company out of San Francisco, Bodyport, has a scale that when you stand barefoot on that, you can get everything from injection fractions to pulse waves to peripheral fluid, et cetera. So these are our data feeds that we have for it. Similar to what was shown in the stress and recovery study, Emma Carlin has put together here a description of the type of usage that are there for I think this may actually be not for BUMP, but for another study, because I see Empatica being used here, but it shows the type of similar rates of adherence. Here is one of those 8 symptoms. The slide here is meant to show what actively we're pulling and passively we're pulling. And the point is, here's one symptom that might have been in ePro, just a subjective question that someone would have in a study, but it shows the depth of the data that we're able to pull and then weave together to see if we can do those maps. I'm going to show, I think it's 3 slides on 7 individuals, because I hope I'll be able to make the point in the BUMP study. So if you look at, so you can see 4 and then 3 individuals, first starting participant 28 through to 192. You can see the weeks into pregnancy leading up to 40 weeks for these 7 individuals. And each one shows one attribute or one feature. So this is one where all 7 of these individuals were following their weight here in kilograms. And the first 2 are sort of what you would expect leading up to delivery. And then we follow these individuals 3 months post delivery. And but you can also see the participant 95, third down, and that dip that's in participant 66. You can also see that these curves are a little different over here. In the second panel, this is individuals who are in the process of becoming pregnant. We have a part of the study where we're following those who are attempting to get pregnant, and we're tracking them after that. So we can go my point is we can go all the way back to around the time of conception and follow in those first week 5, week 10, week 15 similar curves. So that was weight. This is nighttime heart rate variability. And you can see that there is a decrease in nighttime heart rate variability. Second participant down, same individuals, incidentally. Participant 64, you can see how they are decreasing in their heart rate variability at a time that is almost the type of aggregate you might expect. But look at, again, participant 95 and 66. So this is something that if you had gone to an OB or a clinician, you would say the aggregate change during pregnancy and heart rate variability, and you draw a curve. The point, again, we're trying to make is at an individual level. What is it that's causing that? Why is that different? What does that say? What are their interventions going to look like? And quite similarly, those 3 individuals on the other panel, 127 to 192, you can see that their data sets are, again, having not an equivalent change. Incidentally, Adrian, who has done this work at Evidation, many of these figures have come in from his brilliant work with help from Evidation. So that was heart rate variability. The nighttime heart rate, so you can sort of toggle back and forth on these. Again, look at that variability. I hope I've made that point. So now there are a series of studies that we have ongoing. You just saw the data in BUMP. There is one that we have looking at, can we follow immediate, intermediate stress in those that have Crohn's disease? And is there any way to use that information to forecast or predict whether someone's going to have a flare? So you can imagine how that's similar or different. There are 2 studies below that looking at helping enable real-time observations that are on oncology patients who are having for their high-grade glioblastomas and pancreatic cancers out of UHN, looking to see whether we can detect whether someone has a growth, a progression of their tumor before they might come in and say something was wrong. Can we pick up those early signals? Can we disentangle aspects of their chemo from what's going on in progression? And then a study in Sweden looking at diabetes. The studies that we're now heading into are ones that are sort of extensions of our first series. Following on that stress in Crohn's, we're about to begin in Oxford, a study looking at acute MI. So OX, Oxford, acute MI. We're probing this thing that's in the literature or in the lore that after an MI, how one heals from that acute MI is different depending upon sort of how one enters that sense of what has happened and the stress and how one is doing their living. And so we're looking to see whether we can get clues and forecast outcomes after a set of damage initially with Professor Keith Channon and others there at Oxford. The biggest study that's coming, that's going more into the psych aspect, being driven by Sarah Goodday is one out of the University of Washington School of Nursing that we're getting ready to look at whether we can follow 11 symptoms related to mental health over a year in the nursing students and come up with ways of looking at those variations that I've talked about and how that contrasts to the binning that is done in psychiatry now, saying you have depression or you have bipolar or you have that. We're asking when we are able to follow a bunch of symptoms, is there a way to look at an ebb and flow, almost like excursions from where one is, as a way of following the clinical status of participants, the nursing students. And then in later part of the year, there is a large follow-on to pregnancy study bump, where we're more interested in learning about what's happening to women who are beginning to undergo menopause and what are their symptoms, and can we give a voice back to them and strengthen. So as you can tell, almost all of these are, can we find symptoms subjective, and can we strengthen the voice of the participant in order to make better interventions? Last part is that there are a bunch of unknowns that have to do with rebuilding the taxonomies of disease. That last one, next to the last one, my experiences is asking, you know, is the taxonomy for mental health one that makes sense? Trying to take into account the fact that usually when you look at a singular feature, you're going to mess up. So if you look at mood or sleep or cognition, we're trying to figure out ways to untangle sort of causes and consequences in those studies. And then, you know, how do you get this back to individuals, give them agency? What is taken there? And here it's about trying to begin to build communities that could work together, sharing that information. What's the role of the expert? So trying to move towards getting that back to individuals. And finally, there is a project, you may see the thing that I had on one arm and on the other arm, that is about an open band project out of France and at the CRE with SAGE and a number of other groups, asking, can we build an open hardware community that's collecting the data from the devices, open firmware up to the signals, all the way up to sharing sort of insights of participant communities anywhere in the world wanted to do studies. They would have control of the data, where it went, the firmware, how it's measured on up. That's becoming more active. And then last two slides are, if you haven't had a chance to look at this book by Shoshana Zuboff at the Harvard School of Business, it is on surveillance capitalism, and it alludes to aspects in health, but I think it has helped us ask questions about, in any of these studies, almost a moral responsibility to be asking questions that we think are important about who will have the data, who's going to have the knowledge. We're thinking that people are relaxing when they put up a fight on their data privacy and forgetting the more important battle is who's has that asymmetric knowledge, who has the power, and how do we make it so that there is some element of human agency left, because we're very rapidly heading into a world where others are going to be able to forecast what we're doing, as they say, make us dance. I think it's important to have that as a context. And we've been working for a couple of years, haven't got it up yet, implemented. But for these, I started with the medical alchemy, and it's because we just don't have the general rules that allow us to go from one specific set of data to another. And we've got to figure out a way, the way the chemists and physicists and others have, where we have some way of getting those general rules, not just associations, in order to have models that can allow predictions for multiple areas. And one of the ways to do that, the way the mathematicians sort of organized themselves in the 20th century, is like Hilbert's principles. Is there a way to compile a wall of questions to frame key assumptions that if we knew someone is working on this in Toronto or someone is working on it someplace else, while they're working on it, it's the point I'm making, and assuming that you come together and have a way to share your insights, is there a way to frame the key assumptions that we need to work on? And that's an invite to anyone at the Temerty Center who might want to join us on that. So that's the presentation. I hope that has allowed enough time for Q&A.
Great, thank you. Terrific presentation. There were a few questions that were pre-circulated that I can begin with, but if people do have additional questions, please feel free to put them in the Q&A box on Zoom. So why don't we begin by one of the questions that was asked pre this talk. Somebody was really curious about this whole notion of digital tools and AI in healthcare. What are the ethical considerations, and how would you address, let's say, the top few that maybe come to mind as we start integrating more and more digital tools and artificial intelligence into health?
That's a question that nicely dovetails with sort of the end, those last 2-3 slides. So I'm going to extend that answer. So I think the ethical questions should go beyond the focus that most people have, which are 2 questions. I think the hot questions these days are data privacy and whether or not certain groups are being properly represented by the cohorts that are driving the AI engines, right? Those are hot, right? And there are a lot of people talking about them. One interesting thing on the second question about diversity and rules is when you go to an N of 1 level and you start doing the forecasting at N of 1 level, to a large extent, you can overcome, or no, you shouldn't say it, to be very careful. There is an opportunity, possibility to overcome some of the issues around core data sets with assumptions being made about an aggregate. So what I'm saying is, if you're going to train on one place and then take an aggregate learning out of there, the gap to those that were not represented is a big issue. That's hot right now. If you had a way where you could follow individual trajectories for symptoms and look what was the change for that person, that's the way you're always looking at it. Doesn't matter where they're coming from. Do you see what I'm saying? There is a way to get around it. The thing that I think is not as actively pursued is this issue of who has the knowledge, not the data, and how are they using it, and what right do they have to do things that are based on the knowledge that you help them gain. So it's who is using that for what purpose, not the data, but the knowledge. That I hope that's enough of an answer.
Yeah, that was fantastic. Thank you. There is another question around case mix variables, social determinants of health data. What are the sorts of variables that you think we should be collecting to better understand and predict disease and trajectories? I'm going to add one more layer to this. We talk a lot about it's hard to really understand a patient unless you really know a lot of detail about that patient. The very fabric of what makes them tick around social determinants of health, their gender, their ethnicity, their background, their family history. How important do you think these sorts of features are to collect? And is there a human behavior component to this? So
yeah. That's a great question.
Yeah.
Nice questions. So there is a whole engine, like a whole world of looking at risk stratifications. And I'm going to go in on one area. One of the areas where there's like almost a reasonable amount of data is risk stratifications for pregnancy, demographic, various aspects. And there are groups that I think have assumed that if you could like work this together, that you'd be able to ahead of time have a sense of therefore what the risk was for that person in pregnancy. Like what I'm saying, there's a whole enterprise that does this. One of the things that coming from one points coming from is that when we look at the stress that's in those individuals in the COVID-19 healthcare workers study, and you go, okay, well, how many shifts does it take for this to happen? Or what's the link between not getting enough sleep and how fatigue shows up? The thing that is maybe most, we're in a chaotic zone of trying to make sense of things, which is always the most important time. And when we're looking, the direct links between what you might say is those stressors and what it is that's showing up in terms of how what that person is going through are not tightly connected. And also, end of last year, had a chance to go to Gaza, inside Gaza, and work and look at stress there, and looked at the remarkable resilience. People who you would go, well, they were under this, no housing, no parent, no this, no that, So I'm bringing those up because I think incorrectly before, we thought that if we could sort of capture what it was that was the force that was coming on people and the sort of fragility of their end organ, that might stitch together. Now to the point, and I'm glad you brought it up because this is what we've been thinking about, is there a very important middle zone, whether you call it human nature, whether you call it resilience, those things that we were looking at when things were correlated and anti-correlated with other, are there approaches to us dealing with things that we as individuals have and maybe even move all the time. It's not like you put in there's a category of orange individuals or that, but maybe our own way we survive is to actually be going in and out of equivalent of states of how we're able to adjust to what's happening to us, whether it's physical or mental. And that until now, we've not had the details that would allow us to ask that question. So I just sort of loop that together is, what would it take to be able to have more concrete evidence that there is that thing called human nature that is sitting between? And then there's lots of work in general, since I don't want to trivialize, there have been a lot of people who've looked at whether previous traumatic events or others have, but is there a way to make that at an N of one level turn into something that is nonsense, or it's actually a reasonable experiment or exercise to do?
Oh, that's fascinating. Have you experienced much of this sort of phenomenon where, recently I've been involved in some discussions where we want to collect a lot of data on, let's say, ethnicity. I'm using that as one example. And everybody is saying, well, I want to know about how ethnicity is associated with X or Y. And this is coming from minority groups that I've interacted with, including, my own. And of course, then we say, all right, yes, we should be collecting this data. And then all of a sudden, no, I don't want you to have such sensitive information. So is there a bit of a dichotomy there where we want to know more about ethnicity, but people are reluctant to give such detailed information to researchers?
Totally. And I think it's real, and I think it's fluctuating there, and I think it's in the same group, in the same individual flipping. So I think there's a real interest in how is this going to apply to me, and are you able to give me information about myself? And it's equally with, and why are you asking me? Why do you care about me? Because there's a fear of what are you going to do with that. So I think it's the fear of why are you asking, and what are you thinking you're going to judge me as? Are you going to judge me as an individual or someone with this demographic? And so I think there's a total simultaneously push-pull. We've gotten to where for an upcoming component of the BUMP study, where we're interested in looking at some aspects, where the forum goes, if you are interested in giving this, please do. And if you are, here's all this. There's this, I think, I'm not sure we know how to do it yet, but there is this delicate aspect of people not wanting to divulge, and at the same time wanting to know for subgroups for themselves what's going on.
So one of the questions from the audience is, how participant recruitment challenges were tackled among concerns of data privacy and autonomy of choice of access to the data that's shared.
Yeah.
How did you tackle this?
This is really back to work that was started at Sage. I think that without a sense of trust, without a sense that this is something that's being done for a group, without the technical solutions, without the governance aspects, this should be, it's appropriate that this can be a big issue when it comes to recruiting. What I think is the way to the only way to, it's not overcome it, the only way to do this, I think, in a better way is to take the time to connect with communities, to have it so that there's a sense of co-design instead of saying, here's what we're going to do. And so I think the more attention that's on those issues, and they vary from group to group, I think there's such a long way to rebuilding the trust, particularly sadly, Canada and US, a sense that experts are to be questioned, particularly scientist mood that's going around, that this is something that we need to work on instead of go, it's not real.
No, thank you. There's another question from the audience. Did you see any correlation between ethnicity and acute stress? An example, Black mothers have higher mortality. Some argue that this could be partially explained by stress.
Haven't done enough of that. Up until now, the numbers of individuals that would allow us to look at that is not sufficient. It's an important question, and I hope that in a future time, that good question, I can't answer that right now.
Fair enough, thank you. So there are a couple more questions around wearables in particular can be challenging. You know this better than anyone, I'm sure. People are, research data tends to be a little bit more clean than what you would see in the real world, where, you know, I think there have been studies where a lot of people buy Fitbits and then they wear them for a couple of weeks and then they're in the drawer for the next forever. And there's a lot of taking off and putting on. So the Oura Ring, for example, high variability in terms of how long you keep that thing on. So as these wearables become more and more prevalent in society, how do you tackle the issue of maybe incomplete and maybe not so clean data as it relates to these algorithms when you think about real world translation?
I think I can answer, at least put a reasonable stake in the ground. The people who have bought a device and stopped using it are almost always doing it because they're not getting anything out of it. If you look, the people for any device, sometimes it's a very small fraction because there are only some that are really getting anything out of it. But I think that it shouldn't be, oh, that's horrible, that will always happen. I think it's an invitation to go, what is that person getting back? So for the individuals in the bump study, they're, you know, a year wearing their Oura Ring and you know, 80% or whatever, 80% are wearing it 80% of the time or something like that, because they have found something that they want to know. So if it's the real thing is, how do you come up with something that is worthwhile to the individual? And if it isn't, and I think what we found is that it's not how hard is it to get to it, right? You might have thought, right, it's not, no, people will really invest in something that they're getting something else. So I think we need to take these physiologic signals that we were talking about and convert them into clinical symptoms. And if you give someone with rheumatoid arthritis or someone who has a problem with Alzheimer's, you give them something on their cognition, or you give someone on their range of movement, and it's something they want to know, they want to follow, I think the adherence will be very high outside of the study. I think you asked for afterwards, when are these? It's because people are, the devices have yet to be designed well enough that most people are getting enough to be pulled by them.
Great. And if you had to look back on your many years of experience working with with wearables and digital health, if you had to identify the number one big problem you've had to deal with that's kept you up at night, what would that be, and how did you address it?
Oh, it's a hard one. I know it does change. I think the thing that keeps coming back that I meant to mention this concept of we're finally getting into the zone of chaos, right? Until you get to a certain point, you think you're knowing what's going on because you don't have a chance to really. So I would say that even though we've been working on this for a while, I think we're only now getting enough of the data where we're expecting it to do things and finding that it doesn't. And it's at this difference between what does someone subjectively think is going on and what is objectively. So we now have data feeds that where you ask someone, are you having pain? Are you having stress? Are you having this or that? And they give these recordings out and we're looking at them. And the fact that they aren't matching up with the objective puts a real interesting question on, like, well, what are you matching for? Or what matters? And what is the end organ damage? This type of thing. So I think we're evolving into a time when we're beginning to ask questions about what is the difference between what is physiologically happening in someone's body and how they're experiencing. And is that something where the body is, or the head or whatever is protecting you from feeling some things in order to help you in ways that maybe it does or maybe it doesn't help you. Like it's always filtering. Maybe that filtering keeps you from seeing things because your body, your head doesn't want you to be seeing that. Then what are you going to do? So that's the thing that kind of it's keeping us up, but certainly not easy to unpack.
Fantastic. And I'll ask one more question before we break. In data science, in AI, and medicine, and we tend to be very quantitative. We tend to go with mathematicians and computer scientists and such with deep technical expertise. When we're creating solutions for people, for the public, how important do you think it is for us to kind of break down that mindset and maybe work with artists or designers or people who understand human factors and who can build things that people actually want to use and wear? How important does that become when you're even thinking about your quantitative side of things?
Extremely important for many reasons, because I think how to convey, not display, but how to convey and how to have someone be able to have the dialogue with themselves and how that is done. This is where it is extremely important to have the artists, the designers, not just the UI experts. I mean, it is how to bring that to the person where they are is not at all finished in terms of what could be done.
Oh, thank you. And to the T-CAIREM community, I think our motto is this is a team sport. It is definitely not a single player sport where the more people that get engaged from diverse perspectives outside of the sciences and the mathematics groups, the artists and design, I think the more inclusive we are, the better it is for society. To benefit society, we have to understand society. And I think that's an important point that's being made here. So I want to thank Dr. Friend for your valuable time in addressing this group. We're so delighted and thrilled to have the opportunity to hear you talk and provide your perspectives on the work that you're doing. It's fascinating. So really, thank you so much from all of us to you and to spend so much time with us. Thank you.
No, thank you to all.
Thank you. And
looking forward to working together. I think we have a call working together already next week, so it's good.
Oh, fantastic. Thank you. And I'd like everyone to just to make a quick note to please keep up to date by following us on Twitter and subscribing to our mailing list on our website, tcairem.utoronto.ca. Thank you very much, everyone. And until the next time, take care, everyone. Bye.